Today's lesson is on deductive reasoning, and we are getting down to the nitty-gritty now because if you remember, I told you deductive reasoning is what we're going to use to do proofs, and we are going to jump right in here. So let's define it first. Destructive, oh, is that a Freudian slip? Deductive reasoning is the process of reasoning logically from given statements or facts to a conclusion, and that's how we do a proof. Okay, so let's start with a law. This is one that you got to remember you'll use very much. If the hypothesis of a true conditional statement is true, then the conclusion is true. This is called the law of detachment. And symbolically, you know, we have if P then Q. So if that is true and P is true, then this law of detachment tells us that Q is true. So here's what it looks like in an example. What can we conclude, if anything? Maybe we can't conclude something, but let's see. If a student gets an A on a final exam, then the student will pass the course. Felicia got an A on her history final exam. So this is, okay, so we're going to say if P then Q is a true statement. Okay, and what do we have? So this is P, a student gets an A. That's P. This is Q, student will pass. So Felicia got an A, so P is true. Therefore, we can conclude that Q is true. So we're going to say Felicia will pass history. That's as simple as it is to use the law of detachment. Let's look at another one. If two angles are adjacent, so that would be our P, then they share a common vertex. Sharing a common vertex would be our Q. So then we say angles 1 and 2 share a common vertex. So that's Q, right? So we cannot make a conclusion. So we're going to say no conclusion. Because remember, to use the law of detachment to make a valid argument, we have to say that P is true. But this is telling us that Q is true. So we can't draw a conclusion from that. And what I will go ahead and tell you right here is that if you were to draw the conclusion, you know, if we say angles 1 and 2 share a common vertex, therefore angles 1 and 2 are adjacent, that is what would be known as a converse error. A converse error. You remember the converse is when we switch P and Q, right? If we take our conditional and we switch P and Q, then we've got the converse. So if we switch the P and Q in the argument of our law of detachment situation and we draw a conclusion, it's not valid because we've made a converse error. Okay, so let's look at the next one. If P then Q and Q then R are both true, then I can say that, well, then if P then R is true, this is called the law of syllogism. The law of syllogism. And here's what it looks like in practice. If it is July, so there's P, then you are on summer vacation. There's Q. If you were on summer vacation, so there's Q again, then you work at Robex. So there's R. So we have the situation above described perfectly there in an example. If P then Q, if Q then R, then if P then R. That is how the law of syllogism works. It looks a lot like the transitive property, doesn't it? Transitive property from algebra. Okay. All right, so here are a couple of other examples. Why don't you pause here and try to do these using either the law of syllogism or the law of detachment. Pause and do these and then come back and check your answers. Okay, so check out your two problems here. The first one, we have an excellent example of the law of detachment. In B, We have if P then Q, and then they tell us Q is true, so we can't make a conclusion because that doesn't follow the law of detachment. And as I told you, that's a converse error. Make sure you can recognize those. And then there was another one, a C, on the next page. So if you didn't do that, you can just do it with me right here. I'm given if two lines are perpendicular, then they create a right angle. Okay, so if P then Q. If an angle is a right angle, then its measure is 90 degrees. So there's if Q then R. What can we conclude? Well, that is just straight up the law of syllogism. So what I can conclude then is if P then R. And oh, by the way, these three dots that I put here, that's symbolic for therefore. So you'll see that a lot in your math classes. So get used to that, therefore. So what we can conclude is then if P then R, if two lines are perpendicular, then the angles created measure 90 degrees. Okay, and I put something for you to remember here. In order to use either of these laws, the conditional statements have to be true. Okay, so now here's another practice. Let's see. Now we're going to combine these two. If a river is more than 4,000 miles long, then it is longer than the Amazon. Let me label this. So there's P. There's my hypothesis, there's my conclusion. If a river is longer than the Amazon, so there's if Q then R, then it is the longest river in the world. And finally, the Nile is 4,132 miles long. What can you conclude? Okay, so there's P, right? Longer than 4,000 miles. So what I can conclude is R, right? If P, then R. So what we can conclude is, since the Nile is more than 4,000 miles long, then R, the Nile, is the longest river in the world. All right, now another thing you're going to run into is we're going to look at some arguments and decide whether they're valid or not. And guys, please keep this in mind. I can make a valid argument even if it's not true. If it follows the laws, it can be a valid argument even if it's not true. So just remember that, okay? So here we go. If Roger gets a part-time job, then he will buy a new bicycle. So go ahead and label your P's and Q's. That helps every time. Roger buys a new bicycle, Q. So Roger got a part-time job. There's P. So nope, that's not valid, is it? That's not valid because that's a converse error. Converse error. Okay, how about the next one? If two angles are vertical angles, then they are congruent. Angles 1 and 2 are not vertical angles. Oh, so what is that saying? That's not P. Therefore, angles 1 and 2 are not congruent, not Q. Well, that sounds reasonable, and while that may be true, it's not a valid argument. And let me tell you why, because that's what's known as an inverse error. So see, even though I've said something that may be true, it's not a valid argument because this does not follow the law of detachment. You got to go right by the law of detachment. If P, then Q, if that's true, and if P is true, then Q is true. I can't negate them and say, okay, well, that is a valid argument. All right, write yourself a note here if you don't get it, and we'll do some more examples in class. Why don't you pause and do number 3 and see what you think? All right, what do you think about this one? It's not valid, is it? For a minute, it looked like it was going to be the law of syllogism, but they didn't give me the conclusion. Should have been if P then R. So this is not a valid argument. it's not the converse error, because the converse error only occurs if you're using the law of detachment. Okay, so it kind of looks like the converse error, but remember, converse error only occurs, and the inverse error, if you're using the law of detachment. So I had a note written for myself. Why don't you try to write this one over here on the side? I want you to try and write that one so that it is a valid argument. Okay, and when I come around and check your notes, I'm going to look over there and see if you've done that. And then we'll talk about it in class. All right, let's go right on. Oh, and I already said this, the law of syllogism should remind you of the transitive property. Although we haven't really talked about the properties, we're going to do that in a couple of lessons. You all learned about the transitive property in Algebra 1, so that's what that should look like to you. Okay, all I got here is one more example, and I think I do want you to do this one on your own. I'm going to put the answer up, and the table below is something that I copied out of the book. Sometimes they call the law of syllogism the chain rule. I'll never call it that, but you might hear it that way, so just keep that in mind. And they've got Venn diagrams to match these laws. Here's your law of detachment. So make sure you look at that and understand everything in there. If you don't, let me know next time we're in class. And pause right here and do this last problem and come back and check your answer. All right, guys, here are the three conditionals that I came up with based on the statements above. You may have some different ones. There may be more. I don't know. These are just the three that I saw off the top of my head. I did use the law of syllogism for all of them. If you have some different ones that you wrote and you want to try them out on me in class, then by all means bring that up and we'll make sure that you got them correct. What I did in number 1 is I underlined the hypothesis and the conclusion, because I wanted to remind you that the hypothesis is everything after if, and the conclusion is everything after then. So for extra practice, if you want, go ahead and underline the hypotheses and conclusions for your statements 2 and 3. Don't forget to keep making your flashcards and studying them, and we will see you next time when I think our lesson is on Venn diagrams.